So, moment of inertia. So, I start with moment of inertia. If I get late in allowing you to join, please wait, okay? Because I will discuss, and during that time, if I do not get your notification, it may be delayed. So, please wait. Moment of inertia. Moment of inertia. The first thing that we have to consider or remember is that the there are two types of moments of inertia. One is called the mass moment of inertia, another is called the area moment of inertia. So here, basically in your syllabus, we are considering the area moment of inertia. So let me first write that area moment of inertia. Okay. Next point is what is area moment of inertia? So basically, if you have any general area, then we actually have different situations when uh, we have different say force, etc., force conditions, load, force, etc. So how the load is distributed on the area or about that area, how the load is distributed, that uh, we have concern. So that way, uh, we have to understand what is the distribution of area about particular axis passing through particular point. We know center of that is centroid. For area, centroid will be important, and there are two other quantities or centers like center of mass, center of gravity, etc. So center of mass will be important when you have a translation, rotation, etc. And center of gravity will be important when you have basically weight distribution, and that is balancing weight. Most of the cases, center of mass and center of gravity are same, but centroid is a property which is property by virtue of the geometry of the plane or the line or the uh, volume. Now, when you have some centroid, uh, then about that point, the area distribution is basically balanced. Next is if you have some axis, we want to know basically how the area is distributed about that axis. This is actually second moment of area. The moment of inertia is basically the second moment of area. So this is also called second moment of area. And it is denoted with I, inertia, that is I. Both area moment of inertia as well as mass moment of inertia is denoted with I. And it is given by integration. As you know that, say for example, this is some x-axis. So we write Ixx y square dA integrated over the area. So what is y? Y is basically if I take any elemental area dA, then the distance of this element from the axis, that is y. This is y, basically. So this is y, square of that y is this, and this is dA. That is the area. Okay, first of all, is it clear? That means this is definition. That means area moment of inertia is defined this way. So you can look at this as basically as if this is equal to y. Actually, someone is trying to join. Let me allow. Picture has actually changed, so someone is trying to join. Anyways, if someone fails, ask them to try again. Okay. 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 Inform in your group that if someone fails to join, then try again. Okay. Uh, because I am discussing on the screen, so I cannot see the mobile repeatedly. Okay. So y square is basically y dA. You can look at this as this means this way also. So y dA multiplied by y. So this may be called the first moment of area because you are multiplying y, that is the moment arm y, with the area. So it becomes the moment of area. I'm sorry. Okay. I guess you can see the screen, and that means the arrow, this one. this one. So this is y dA, that is the first moment of area, and then I multiply with y again to get the second moment of area. So y dA multiplied by y. So it can be looked at this way also. Again, it is integrated over the area. Okay, so that is the definition. Again, if you have some other axis like say this, so this is y axis. So I can write y as, so the distance of this point is basically a distance of this element is x, and we can write x square dA, that is over this area. So that is the definition. Okay. Next, uh, therefore, by using this definition, you can get or derive or determine the area moment of inertia of this area about any axis by using this definition, because this y can be defined about any axis and therefore we can determine the moment of inertia. Okay, first of all, this is the case. Next is there is a transfer axis theorem. That means when we have some knowledge about the moment of inertia about some axis that is passing through the centroid, then we can transfer or determine the moment of inertia about some other axis which is parallel to the centroidal axis. That is called parallel axis theorem. So what is the advantage of this? Advantage is that we need not calculate again and again. Only if I know, say for example, this is x. Now, say for example, this is the centroidal x-axis. If you cannot follow, then please remind me, okay? Do not just listen, because then in that case it will not be a doubt clearing. If you are unable to follow, please tell me. Say this is the centroidal axis. This cyan color, light blue color uh, line, that is the axis passing through the centroid. So this is the centroid. This one is the centroid. I guess you can see the uh, you can see the this one. Can you see the highlighter?
Yes, sir.
Red color highlighter. Is it visible? Okay. So, okay. Now this is the axis, that is centroidal axis. And this x-axis is any other axis parallel to this. So just how to transfer? So Ixx Ixx say Ixx which is this axis, which is parallel to the centroidal axis, and x prime is the centroidal x-axis, then it is I x prime plus, now these two axes are parallel, so we can measure the distance. So this is, say, some y say d, you can write yd, or you can write d simply. You can write simply d, the distance between these two axes that are parallel. So it will be basically d square multiplied by area. So if I know the moment of inertia about the centroidal axis, then simply by adding d square a with that, we can get the moment of inertia about any other parallel axis. So that is one thing. Okay. So that we have derived, and if you have any doubt in the derivation, you can tell. Was the derivation clear? Parallel axis theorem. So that was the final outcome. In the derivation, it was actually, the key was, if you have, say, this one, that means this dA is having a distance of y from xx and y prime from x prime. So you can give a different color for that. So say this is, say, y prime. That means same area having a distance of y from x axis and y prime from x prime axis. Okay. Therefore, you can write that y is equal to y prime plus d, that you can write. Again, if you just determine the values of x prime and ixx just by using this definition, so what you will get? Let me show. So let me show these two differently. That means this one and this one. Okay. I think it should be interactive. Okay. If you do not understand, if you have any difficulty in following, please talk. Otherwise, how can I know that you do not understand, or you have any difficulty? Okay. Please do not be shy, or just do not be mute. Please ask any question. Okay. Ixx, if I write, so what should I write? Can you tell? What should I write? Ixx. Using the definition, this definition. What should I write? Can you tell? It will be simply, are you following, all of you? I do not know whether you are following. Okay, okay. So please try to interact. Okay, this is an interactive class. So it will be basically xx means basically whenever I write this, whenever I use this definition, this y basically dA is common. You see that dA, this dA is common to both the axes, but this y is the distance of this dA from the particular axis which I am selecting. That means this is x, and therefore this y is the distance of this dA from that x axis. So this y is the distance of this dA from this x axis. Therefore, if I change the axis, then accordingly y will change. Okay, is it clear? Therefore, that particular definition we have to follow. So it will be basically y square dA integrated over the area. Okay. That first thing you have to understand. Then, therefore, you can write, just expand this y, because you know this y is equal to y prime plus d. So you can write, you can expand. So I prime plus d squared multiplied by dA. Right? Now, what is I x prime x prime? This one. What is I x prime x prime? This is from the definition again. We can write the same way. Simply y will be y prime in here, because that is the proper relevant distance. So y prime square dA. Right? So that is this. Now, if I basically expand this, it will be y prime square plus 2y prime d plus d square into area. Here it is this. Okay. Now you just distribute this. Therefore, it will be y prime square into dA over the area plus 2. Now d is constant because d is the distance between the two axes, and these axes are basically fixed. Therefore, the distance is fixed because this is chosen by you. Okay, it is not varying. This is the centroidal x-axis, so that is also not varying. Therefore, the distance between these two is known. Okay. So when I basically change this, that means the over the area, I am not changing. So we have to understand that. That means during the integration, I change the area location, but I do not change this axis, and definitely this axis is also known, that is fixed to the centroid. So during integration, neither of these two changing. Clear? Therefore, this distance d is known and it can be taken out. So 2d can be taken out of the integration over the area. That we have to understand. So it will be 2d integration over area y prime dA plus, now d is constant, so d square, or d is known, you can say, means for this integration d will not vary, therefore it can be taken out. Okay. Now you see that what is this? This is basically this one. Right. I x prime, right? Right. X prime. So that is the area moment of inertia about the centroidal x-axis parallel to x, right? So I can write x prime, x prime. One thing we have to understand that why I am writing x prime or xx uh, twice I am writing, because just keep in mind that this is one tensor of second order. Okay, that is why I am writing two indices, x or x prime. Okay. So in some book, you will find that it is simply x. Okay. As a quantity, this is all right because this is about x-axis. But when we consider this as a tensor, then in that case, mentioning both the indices are important because it can be a product of inertia, and in that case, it will be x, y, etc. But in your case, product of inertia may not be that important. So simply understand that. Okay, this is basically that is why we are writing it twice. So actually that is a physical quantity and that has some relevance. That is why we are writing it twice. Okay. Next what? You see that y prime dA, this is what? That is the definition of the centroid. That is the definition of the, that comes from the, or that is related to the definition of the centroid. Now what is therefore y prime dA? Can we try writing that? That is basically, if I try to write the y coordinate of the centroid about the centroidal axis, x-axis. So what is that? Y c prime means what? The distance of the centroid from the centroidal x-axis itself. That means distance or the y coordinate of the centroid from the centroidal x-axis itself. So that means from this x prime axis, what is the distance of the centroid? You see that the centroid is on the x-axis itself. Therefore, the distance of the centroid from the x-axis is 0 because this is situated on the x prime axis itself. So this is the x prime axis and the distance of this from itself is 0. Therefore, it is 0. Now, what is the definition? This is 0, right? Because it is situated at the axis itself. Means the axis is situated on the centroid itself. Because this is this. Therefore, it is this. Now, what is the definition? That means it is numerically 0, but what is the definition? Definition is equal to y prime dA divided by dA, integration over area. That is the definition of centroid from any axis or about any axis. Now, this area cannot be 0. This denominator area has some positive value. Means here we are considering definitely positive value. So therefore it is A. That means this is A. Therefore, we can write that y prime dA, this one, the numerator I am mentioning, numerator over the area is equal to yc prime, yc prime into dA, right? Yeah, you can directly write area exactly without further delay. You can directly write this. You can directly write this as area. This one is area, therefore we can directly write this as area. Now what is y prime c? This is 0 because this is situated at the centroid. The axis is passing through the centroid, therefore this is 0. Therefore we can write that this is 0. Can write that this is 0 because passing through the centroid. You can write the x prime being the centroidal axis. Yc prime will be 0. Therefore, it will make this 0. That means the left hand side 0. Therefore, this term will be 0. Therefore, you can write y prime dA is equal to 0. So that is the first thing that we have to follow. That is the first thing that we have to follow. Okay. Therefore, this will be 0. Therefore, this will be 0. Therefore, this term will vanish. You have to write the proper explanation because this being passing through the centroid, therefore this will be 0. And what is this? This is simply area, we know. So it will be d square into area. Therefore, you can write that this x is equal to this. I guess it is clear. Any doubt for anyone? Is there any doubt how it is coming? Or any kind of conceptual question? So once you know this, the remaining thing will be very easy. Okay. So this is now in this case you have to understand that one of these, this one, the right hand side, the first term, it is basically the moment of inertia about the centroidal axis, and this x-axis is parallel to the x prime x prime. That means what is the relation between x and x prime? They are parallel, and x prime is passing through the centroid, and d is the distance between them. Okay, that is the parallel axis theorem. Now we have perpendicular axis theorem. So I'm just let me briefly discuss that perpendicular axis theorem. Then I will show you how to calculate perpendicular axis theorem. So here basically we have some laminar area like this. We are considering this only. First, we are considering this type of area, then actually it can be shown that it may not be always laminar. Only thing is that two axes will be on this plane and the third axis will be perpendicular to the plane. Okay. So I will show first one axis, that is, say this one. Then say this one is one axis. Then we have some other axis, say like this. Next, we select an area, small area, somewhere here. Say, right? So this one. Next, what is the distance of this from these two axes? Let us try to show. So the distance of this from the red axis, that means along the green axis, it is this one. So say the green axis is say x-axis. So this is x-axis and the red axis is a y-axis. So this green line, this green dashed line, it is along the x-axis. So let us call this distance as a small x. Along the x direction, so it is small x. That is the distance along the x-axis. And similarly, the distance along the y direction, it is y-axis. That is y. This is the y distance. So this is y, small y. Okay. Now we can say that this distance, say this is r. That means this is the origin. The two axes intersect at the origin. So this is O, and that distance of this area dA from the origin is r. Therefore, we can write r square is equal to x square plus y square. Exactly. So that is the polar distance, you can say. And you can definitely measure one polar angle, that means circumferential angle. That is basically not polar angle, I'm sorry, circumferential angle. In this case, uh, So that is basically theta. That is also called actually azimuthal angle. So anyways, theta. So we can define this. So that is r. R is a square of r is equal to x square plus y square. Now, therefore, if I try to write the definition according to definition, so what is that? Ixx. Can we write Ixx and Iyy? Simply, we will write from the definition as y square dA, and this is x square dA. Now, if I add them, Ixx plus Iyy, they will make x, that is y square plus x square dA. Is someone trying to join? Okay. 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 So this is this. Okay. Now, therefore, we can write this as r square. So Ixx plus Iyy is equal to r square dA. Now, if I now draw one axis, which is basically, say, orange color, that is passing through this same the point of intersection passing through O but perpendicular to both the axes, then it will be like this, right? Now, what is the distance of this element, that is dA, from this axis? That is nothing but r, that is the perpendicular distance, right? Therefore, if this is z axis, if this is the z axis, then I can write from the same definition that Izz is equal to r square dA. Therefore, I can write this as Izz. So, you can write that Izz is equal to Ixx plus Iyy. So is it clear? Therefore, that means when you have two axes on the plane and we know the moments of inertia about these two axes, then by adding these two, we will get the moment of inertia about the axis perpendicular to both of them. That is perpendicular axis theorem. This is also called polar moment of inertia. This left hand side, it is also called polar moment of inertia. And in some book, you will find that this is denoted with capital J instead of I. Okay, you will find that. So anyways, you can write IZZ also, no problem. In some book, it is denoted with capital J. A capital J, sorry. That is polar moment of inertia. Polar moment of inertia. Okay. Okay. So these are the two theorems by which you can transfer the moment of inertia. This is one thing. Okay. Now regarding any particular say situation when you need to determine the moment of inertia, then we can apply the definition or the basically transfer axis theorem. Okay. So say for example, if you want to determine the say moment of inertia of say this area. Now remember these all are basically area moment of inertia. Say we want to determine the moment of inertia of this or any other shape you can do. So So this is the shaded area for which we want to determine the moment of inertia. We may need to determine about any specified axis. So first of all, we have to know about which axis we want to determine the moment of inertia. Okay. As for example, if we want to determine the centroid, so centroid is a particular point, isn't it? But if I want to determine the location of the centroid, that location means what? It is a distance measured from some particular axis. So if I want to determine the centroid, then what we have to do? We have to first locate the axis from which we want to measure the centroidal distance. Okay. So that we have to know. Therefore, first knowing the axis is important. So for example, this is the axis from which I want to measure the centroid. Centroid is simply a location, right? So it may be somewhere here. I want to measure that somewhere, that means that point from this axis, right? Definitely, if I have some other axis like this, then the distance will be something else. Therefore, knowing the axis is important. So whether it is centroid or moment of inertia, for both the cases, we have to know from which we are measuring. Okay. Uh, the difference is that for centroid, it is a fixed point, but moment of inertia definitely about different axes will be different. So that we have to understand. As the axis changes, the moment of inertia will change. The location of the centroid relative to this surface or plane is a fixed point. As the distribution of area is not varying, as long as this area is fixed, the centroidal position will be fixed relative to this area only. Okay. Next, we have to determine the moment of inertia. So there may be two methods. One is, no, okay, first of all, what we have to determine, say for example, we have to determine the say moment of inertia about this axis. Say for example, say 1. So this is say x. We have to determine the moment of inertia about the x-axis. So how to determine? Can you tell? One is we can apply directly the parallel axis theorem. So if I want to determine the moment of inertia about this axis, I can use the parallel axis theorem. Now I know the centroid. What I will do basically, first I will basically segregate the whole area. I can consider this whole area as a composite area. That is the first thing that we have to identify. So composite area. So composed of regular shapes. Composite area means the whole area is not a regular area, but it can be decomposed into regular shapes. Regular shapes means basically circle or semicircle or quarter circle, rectangle, square, etc. or triangle. Because for these we can easily determine the moment of inertia, or these are basically available on in tables. Okay, so that first thing we have to basically we have to means understand. Okay, that is the first thing. That means why we are going for decomposing, because that is basically you can say that divide and conquer. Okay, because you know the moments of inertia about the regular figures, for the regular figures, you can easily do it. That is the thing. Okay, that is the thing you are doing basically. Okay, is it clear? That is why we are basically decomposing. Okay. So, so what we do? Basically, we mark them. Say this.